Hello students, let us discuss today the 8.6 topic, electrical energy of 2-point charges, 2-point charges and of a dipole in an electrostatic field. As you know, the electrostatic potential energy of a system point charges is defined as total amount of work done to assemble the system of charges by bringing them from infinity to their present location. Just will remind that definition, that is electrostatic potential energy. Okay, potential energy of a system of point charges is defined as the total amount of work done total amount of work done to bring or to assemble the system of charges by bringing them from infinity to their present locations. Okay, it is very simple. Now suppose here we are considering a source charge. Q is a source charge, and let us consider here somewhere the positive test charge is kept at infinite level. Okay, this is the position A, and somewhere here this n position, this infinite distance, at infinity this point is kept, q0, the charge is kept, positive test charge we can say. So at this position n, the potential energy of this charge is 0. Okay, at infinite distance there is no potential energy, so there is no force of attraction between them and all, and so the potential energy becomes here 0. Now you can see here these two charges are positive in nature. So what type of force will be there? The force of repulsion will be there, and because we are considering this is a source charge, and so we can say this is fixed relative to this, and this is only moving. Okay, so what will happen when these test charge are near to each other? There is a repulsive force between them. Okay, so what is the direction of the repulsive force? It will be away from it, isn't it? It will be away from this. So this will be the direction of the force, we can say, in this direction. Now we are bringing this charge from infinity distance to somewhere here at finite distance. Suppose let us consider this is the position B, where we are bringing this charge from infinite to this distance. Okay, the same charge we are keeping here now, the positive test charge. So when we bring this charge from infinite distance to this, then the work is done, because we are displacing it against the force. We are applying some force here which is against the electrostatic force of repulsion. Okay, and that's why it is moving from this distance to this distance, and now it will be fixed at this distance. And let us consider this distance between A and B is something R. So when you're bringing this charge from infinity to this, so work is done against the electrostatic force, and that work done is nothing but force into displacement. So whatever displacement is done here, suppose we are bringing this infinity to this, that amount of charge, let us consider it is dx. So work done is equals to F into dx. So this amount of work done is now stored in this, at this position in the charge, or you can say in the system. Okay, so potential energy is nothing but the work done. So we can say potential energy is equals to work done here to bring the charge from infinity to infinity to the present location. We can say here present locations. So if you are bringing one charge from this somewhere here, the infinite distance, another test charge is there, you are bringing here, it will be here. So total now this is the R1 distance where you are keeping this charge, test charge. So in this way, in the system, if you are increasing the charge, then the potential energy of the system will increase. So in this way, it depends upon the number of charges over in the and what is the work done. It will depend upon the potential energy, will depend upon that work done here. Now let us consider this in more detail with small examples. Let us consider here I am taking one a spring. Okay, this spring is in the its original form. It is not compressed or stretched. Okay, now one block is attached to this spring and one ball is kept over here. Let us consider here this ball with another color. So we are bringing here, we are keeping here the ball very near, we are attaching to this. Okay, so is there any force on this ball by this block? No. So we can see here now this potential energy is zero here, no potential energy, and that's why it is not working on this ball. But let us consider here, this is the position A, we can say, and this is somewhat position C, we can say. This is the position C of this ball. Now let us consider here we are applying some force, and from this we are moving this block from this position to this position. Now this much displacement is occur over there by to shift this block from this position C to B. Okay, this is C position now, this is B position now. From this to this, how much displacement takes place? Dx. Now the same spring is there, now it will get compressed, isn't it? Yes, it is now compressed. So in this form, if I release this, so what will happen to this? Now the same ball I am keeping here. So what will happen to this ball? It will go pushed by this block when it is released. So from where this energy came in the block? this energy in the block now is due to the um, force to move this block from this position C to B. And because of this force applied to move the block from this C position to B position, work is done, and that work done is now work done. Okay, and that is force into displacement, we can say. So force into displacement, and this work done is converted into the potential energy of the system. Now it has this has the potential energy. The system has some potential energy, and that potential energy is equals to, we can say, that is equals to work done. Are you getting? So now here same thing is happening. Now what I'm doing here, this is the positive charge I'm taking, this is a source charge, we will say, and the another charge I'm keeping somewhere at infinite level, that is also positive charge, q0 charge. From infinity to somewhere here I'm pushing it. Okay, why I'm pushing it? Because the electrostatic force of repulsion will be there, because two charges are opposite in nature, and that's why when I'm bringing this charge from this position to this position, some work has to be done, and that work done is nothing but force into displacement, and that work done is converted into the potential energy. And that potential energy, when we are bringing this charge from this position, infinite position, to B position, already this is A position. Now when you are bringing this charge from infinity to this B position, then due to this force into displacement, the work is done, and that work done is converted into the potential energy. Are you getting? So you have the work against the electrostatic force F here. It is the direction of electrostatic force in this direction, and you are displacing the charge in the opposite sense. So whatever energy you are storing here, that will be the potential energy. And which kind of energy it will be, either it is positive or negative, how will get it? So it will be positive charge, positive energy, because you are working over there. The potential energy, whatever is there, that will be positive. Now let us consider here now, this is the positive, sorry, this is negative charge, source charge I am considering negative Q, and because I am always considering the test charge as positive, so here test charge I am considering again positive. What will be the electrostatic force between them? There is a force of attraction, so the direction of the force is in this direction only. So from infinite level to this position again, and B position I'm taking this charge, then again the force is done. Is it? No, because already here this is the attract force of attraction, and due to this force of attraction, electrostatic force of attraction, the charge will move from this position to this position. So work is not done here. So now here with high velocity it will move, and we have to stop here for this position B. Now the kinetic energy will stop here, and so whatever potential energy is there, and that will be negative. How? Because at this position potential energy is already zero, and if the charge, if due to this force the charge is moving from this to this position, some energy will be loss, some energy loss will be there, and due to that, that becomes 0 to negative. So the potential energy here stored, that will be negative. Let us consider with the formula. So we know the potential energy, the electrostatic and electrical energy, we can say electrical energy is nothing but work done, and that is equals to 1 upon 4 pi epsilon 0 q, the amount of source charge we are taking here. Q0 is the positive charge we are taking now, and here the distance between them. Which distance? Final distance we are considering here, the distance between the present location of the Q0 point and the source charge. So that is R we are considering here. Okay, so now here in this case, if both the charges are positive, then what will happen? So it will be now here 1 upon 4 pi epsilon 0, q is positive and q0 is also positive, so whole thing will be positive. So u is again positive, we are getting the potential energy or electrical energy, that will be positive. But in second case, now this is the first case we are considering, now second case in which we are considering both, nice, source charge is negative, and test charge we are considering again positive, then what will happen? So u will be here now, that is 1 upon 4 pi epsilon 0. Similarly here the source charge we are taking negative charge, and the test charge will be positive. So what will be the thing here? Now total this system becomes negative, isn't it, due to this negative sign. So here we are getting this as negative. So remember this thing, this is nothing but a dipole, isn't it? Minus and plus charge separated by finite distance. So we can say when the dipole we are considering, that time the potential energy or electrical energy we can consider it as negative, and if the two charges, positive test charges we are taking, that time the electrical energy, that will be positive. You have to remember this. So this is enough in this lecture. In next lecture we will discuss potential energy of a system of 2 point charges. Till that time, have a nice day. Thank you.